Hey everybody, hello. Who was here in my last session? Who was, okay, I'm sorry about that. We had to get moving, and I didn't have time to do anything, so there we go. We moved, we got through it. Now we got a little bit more time, we got a little more breathing room. So that was my nerding out a little bit session. This is my, I don't know, nerding up a little bit session. So I'm Stephen Foskett. Those of you who don't know, which is probably most of you, one of the things that, the reasons that Roger and folks, the Deltaware folks wanted me to be here is because I don't work for any of these companies. In fact, I work for no one. I am completely independent. My money comes from writing and speaking and organizing events, which means that I don't care what I say. And if I piss you off, I'm sorry. Oh, I guess I do care about it, because I'm sorry about it, because I'd rather not, but you know, there's that. So I'm not here to try to pitch anything to you. I'm not here to try to tell you to buy something or not to buy something. In fact, I'm going to try to not mention products at all unless you happen to ask me a specific question, in which case I will happily tell you, right here on the record, I guess. I'll tell you what I think of anything you ask about. Good luck with that. So I'm going to talk about which products are ready for the data center, but I'm not going to talk about products. I'm really going to talk about the data center. So let's flip it on its head. So first, let me tell you who I am. Everybody has these ridiculous intro slides about showing like all their qualifications and awesomeness. So I figured I would put a similarly ridiculous info slide together. So this is who I am, because I'm actually a lot more than just a storage guy. I mean, I imagine that you guys are too. I imagine most of you. Like, I think if I got to know you a little bit better, I think if we sat down and talked, you'd be really interesting. Are you? Is he interesting? Does anybody know this guy? Okay. So I think he'd be totally interesting. And I found that as well. Every time I do these presentations, if I get to know somebody, I always, what I want to ask them is, tell me something about you that is not your job, not related to your job, not related to anything about you. And you always find so many amazing things about people. Like, I met a guy who ran drugs and guns in Africa when he was a kid. Seriously, at one of these events. And he's in your data center. So there's all sorts of crazy stuff. Sorry about that, buddy. Yeah, he was on the other side. All right, so you've heard a lot about products, and you've talked to some cool companies in there, and you've heard about what they're developing. Your question now is, okay, that's great. Should I even consider looking at these any further? How do I make that evaluation? How do I decide what I should buy and what I shouldn't buy, what's good, what's not good? And that's a really, really fair question. Like I said, I was a systems administrator for more than 10 years. I had pitches from companies constantly wanting to sell me their new thing. I had to put together RFPs and compare this thing versus that thing. And I'll tell you now, I did those totally wrong. Because what I would do is I would always take the nerd position. The nerd position is, which one should I bet? Which one should I buy? I should buy the better one, right? Given the choice between two things, I should buy the one that's better. Is it faster? Is it bigger? Is it, something, right? Is it objectively better? Well, objectively better is not better. Better is what gets the job done better, right? It's what does the thing that you need the thing to do. And so that's why I'm asking you, what's your strategy? What are you trying to build, right? Techies, we love cool stuff, right? We love things that are objectively better. But what are we actually doing with all this stuff? And what is it really buying us? What is it really getting us? And for that, I think we need to take a momentary diversion into a different world, and that's the world of IT strategy. Now, dude, I'm going to call you out. I'm sorry. I said no products, but I can call out people, right? So we were having a conversation earlier about this. Effectively, IT is divided in half right now. We've got two things going on. We've got, run the systems and change the systems going on. I used to work for a bank, and they literally had two groups, and the groups were called Run the Bank and Change the Bank. And I think that's really a good strategy for any IT company, any company with IT to do. Basically, we have a push and pull between sustaining things and transforming things, right? Are we going to keep the systems that earn the money running? I'll just give you my slides, man. I'll put them on SlideShare. I know that you love my graphics, man. I know you. Anybody recognize that? Anybody? Come on, nerd it out. Okay. Yeah, absolutely. And that's the real one, not this new movie one. So there's these two conflicting demands on IT. And essentially, classically, the beleaguered IT guy in the cube farm focuses all his time just keeping things alive, right? Sustaining IT, keeping people from complaining, right? That's his strategy. His strategy is don't get fired, okay? That's not a great strategy overall. But it is a strategy, and it is important to do that because, of course, if you can't keep the systems running, if you can't keep the company running and do whatever it is the company does today, well, then you won't have any opportunity to do whatever the company's supposed to do tomorrow. And I think that some of us get too wrapped up in cool new future things, Docker, OpenStack, we get excited about these new products, but we forget that Fiber channel, we've got to keep things going. We've got to keep things alive. And so my first suggestion for you is when you're looking at products, when you're looking at technologies, ask yourself a very simple question. Is this product a sustaining product or a transforming product? And then you have to ask yourself the hard question, which is, do I need a sustaining product or a transforming product? Do I need something that does what this thing does? And we're going to get into that in a lot more detail. But let's first talk about sustaining IT. So the goal of sustaining IT, number one, is get out of the way. There should be no IT. IT should be not even an afterthought. It should be a non-thought. Essentially, the systems have to run, and your job is to make that happen go away, right? This means that we have to focus on things like reliability. Reliability is paramount. And so again, you're looking at products and you're thinking, oh man, this thing is so cool. Is it reliable? Is it going to be reliable? Is it going to be supportable? Is somebody going to be there when I call the phone? Because again, as IT guys, one of the hardest things for us to admit is that we don't know something and we can't work miracles. That was really hard for me. When I got my first IT job, people would ask me to do stuff, and I would say, sure, I think I can do that. And then I'd go try to do it, and I wouldn't really worry so much about asking for help, asking for expert advice, checking with the company to see if this is a supported solution, all that kind of stuff. I would just say, okay, I'm going to stick this thing in there and plug this thing in here, and yeah, that seems to work. I'll say that's good. Systems have to be supportable. They have to be supportable in the long haul. They have to work. They have to provide the level of performance needed. They have to grow. They have to adapt. This is sort of like the table stakes on that side of the equation. On the other side of the equation, though, is very different. If you're going to transform IT, you have to make an impact. And how does IT make an impact? IT can deliver huge benefits in terms of efficiency. True fact. Ready? True fact. The average transformative, I'm a storage guy, so I apologize. The average transformative storage product is easily an order of magnitude more efficient in terms of dollars for performance and for capacity than the average sustaining IT product. In other words, if you go out and buy a best-of-breed SAN system to run your ERP system on, that guy's going to be reliable, it's going to be supportable, it's going to be great, but it's also going to be easily 10 times more expensive than a system that offers similar levels of performance, similar levels of capacity, but is totally not suited to run an ERP system on. And that's the opportunity, and that's why, as IT people, we have to start looking at both of these things. We can't just sit there, keeping the lights on. Because if you keep the lights on, you may keep your job, but where's the fun in that? You don't want to keep your job. You may keep your job, but you're not going to really make an impact on the business. If you can really build transformative systems, you can really make an impact. And, of course, transformative stuff is cool, right? So as an IT nerd, as somebody looking out for my own career, I want to work on the cool stuff, right? I want to work on this, all this advanced, clouds and stacks and platforms and stuff like that. I don't necessarily just want to plug in fiber channel cables all day. So what are we going to do? How are we going to consider products? We have basically a fork in the road. We've got sustaining on one direction, we've got transforming on the other, and we've got to look at these products, and we've got to say, which one am I supporting? Which one do I want? Which one do I need? And frankly, if you're on the sustaining side and you've got to keep IT going, you should just forget about looking at the transformative stuff, because it's just going to make you cry, right? It's way cooler, but it's just going to make you sad to see what's going on outside the walls of keeping things running and keeping the lights on. Similarly, if you're in the situation like we have here, where we were talking about earlier, you're on the transformative side, just walk away from those sustaining products. Basically, if it runs fiber channel, yeah, sorry. Point being, it's just not transformative. It's not a transformative technology. Don't even bother with it. It's not going to deliver any of these, any real massive benefits. Yeah, you said, yeah.
Walk away from sustaining?
No, and in fact, this is a false dichotomy, because I think most companies have to do both, and even sometimes most people may have to do both.
Well, companies certainly do at the individual level.
I think it might help to pick a path. Now, there's cool stuff on both sides. There's cool stuff down both roads. The reason I say it might help to pick a path is because it's a real paradigm shift, and it's a real mental shift to go from, always consistent, high availability architecture, in the traditional sense, things like clustering and things like, ACID and SQL databases and things like that. It's a real mind shift to go from that to eventual consistency and sharding and scale out architecture. And it may be difficult to walk both those paths. Do you agree? That's a real good point. So what he says is if you walk down the sustaining path, you can get sucked into that, because there's always something to be done. There's always another backup to be made. There's always another DR test to fail. And it's important, that somebody keeps attention to that, and you may not ever be able to transform. And probably a lot of companies face that question too. If you're the CIO, and you've got a system, oh, my reservation system, yeah, it runs on mainframe, but it works, do I really want to do something different? Do I really want to do something new? And I think this is one reason too that a lot of these, cloud technologies that we're all kind of secretly lusting after and think are cool are kind of out of reach of normal companies, because the normal companies already exist and they already do stuff, and whatever they do kind of works. Whereas if you were going to start a new company, it's a very different question. Like here's a good question for you. Okay, so I'm just going to pick an industry. Let's say that you and I got together and decided, hey, we're going to start a brewery, and we're going to make the best beer, and it's going to be totally awesome, right? Okay, we need some IT systems. The question is, what's our first step when we're still a startup, right? Are we going to buy a data center and equip it with a mainframe and write a COBOL application to track? No, that's stupid. Forget that. I was just kidding. Of course, we would never do that. Okay, are we going to buy some Windows servers from Dell and run SQL Server and stuff like that? I don't think so. Are we going to run Exchange? No way. I started my own company 5 years ago. You know how many servers I have? I still have none. Why? Because that would be stupid, right? I would never. Why would I have servers, right? So I use, software as a service for email. I use software as a service for ERP. I use it for everything we do. It's all running in the cloud. When I needed applications, when I need stuff done, my first thought is, can I run this on Amazon? Can I run it on Heroku? Can I run it on Google? Can I run it, and build it in this new world, right? Every company is like that. And every CIO, if they're if they're thoughtful, every CIO that's thought about this question has decided the same thing, which is it would be foolish to build more conventional IT. But I guess if you already have conventional IT and conventional applications that work, it would be foolish to just walk away from them. So I mean, it's kind of this whole road, this whole path of which way am I going to go. I think most companies are going to go both paths. And I think over the long term, most companies are going to make a decision. Even the oldest, most established companies are going to make the decision that future stuff should run on future infrastructure, not past infrastructure. And maybe that's going to be a personal thing. Maybe that's going to be a challenge for a lot of those CIOs who've been in IT for a long time to make that call. But I think eventually they will. Maybe not today, maybe not tomorrow, but soon, right?
I think that may be easier from when you have 5, 10 users for a company. But if what happens if your company becomes 10,000 users?
Yeah, really. What happens if you have to index the whole internet? That's going to require a really big mainframe.
Exactly right. So the cloud can be too costly for you to
Yeah.
operate. You have to release that cost time again.
Yeah, and okay, that's a good point. I'm not saying outsource cloud companies off premises. I'm not saying that at all. What I'm saying is architecture. And what I'm looking for is, I think that the transformational IT stuff does not have to run on Amazon. Cloud doesn't equal Amazon. I think most companies are increasingly going to have their own platform as a service. Microsoft, not sure how much detail I can go into about this. Microsoft recently announced something called Azure Stack, which is essentially your own Azure. And it's not, before they had Azure Pack, which was basically something like Azure that runs in your own data center. This is actually Azure that runs in your own data center, okay? And so you can have your own truly transformational platform as a service and not pay Microsoft and not pay Amazon and not pay Google and all that. Same thing, OpenStack, absolutely you can run that in your own data center. You are totally correct. And in fact, I think one of the biggest fallacies of a lot of these cloud companies, where cloud to them means run it in our data center, is that this is always going to be cheaper than running it in your own data center. I think that's foolish. It probably isn't ever going to be cheaper. And in fact, I talked to one company, a product company, that what their model is now, they've made this decision. All new software development is cloud platform development. So everything runs on scalable cloud systems, not on conventional systems. Every new product is deployed in Amazon to see how it works and to see how it goes. But the goal is that after maybe 6 months, all those products are pulled back in-house because it would be foolish and it would be too expensive to run on Amazon forever. Some companies haven't made that choice. I mean, Netflix got rid of their on-site stuff and and went back to all outsourced data center, outsourced cloud. But I think most companies, most of the people in this room, once you get to the point of making this decision and saying, okay, we're going to develop a cloud platform application, you're going to say, we're going to run that in-house if we can. I think that's the long-term decision. So that's a real good point. It's probably not cheaper to run it on Amazon. But it probably is cheaper to run it. In fact, it's probably substantially cheaper to run it on a cloud platform than on a traditional system. Yeah, it depends on what you're building, yeah. And I think that's the other thing too we got to recognize is that a lot of stuff was not meant to run. I mean, basically, that's why I put it as a fork in the road. Because it's foolish, you don't want to run Exchange on Amazon, right? I mean, how stupid would that be, right? You don't want to try to run that. You don't want to try to wedge it in there. You could probably do it, but that's not what it's meant for. It's not what it is. It is supposed to be run on conventional servers, on a conventional monolithic architecture. Similarly, you don't want to build, a scale out, client-facing application on, on conventional monolithic systems anymore because it doesn't have the flexibility, it doesn't have the scale, and it doesn't have the performance that you're wanting. So, yeah, so that's a thank you for saying that. Don't confuse cloud for somebody else's cloud. It just means cloud. And I want to talk about that in a little bit more. But let's go back here. So again, how can you look, when you're looking at products, how do you know if it's any good? So let's focus first on the conventional IT side of things. So start, frankly, with support, not with performance, not with features. Because, as a wise man once said, if it's on the market, it's probably at least reasonably good. in terms of performance and features and so on. Maybe if it's brand new, it doesn't have what you need. But basically, support is what's going to kill it. If you can't call somebody and have them answer the phone and answer your question, then you can't buy this product. And unfortunately, for a lot of new companies, a lot of young companies, this is something that they overlook. They'll outsource their support to a third party. I talked to one company who, again, I'm certainly not going to name this company. They hired an answering service to answer the support phone calls. And the same answering service was used for home health care, telemarketing, all these other things. And so somebody would call it up, hello, is this XYZ Technologies? And the person on the other end would say, yes, sure, yeah, I'm XYZ Technologies. And the person would start asking questions, and not supported, not well supported. On the flip side, there's a few companies that have raised a huge amount of money. One of the things that those companies have spent a lot of that money on is basically having somebody answer the phone and having somebody who answers the phone know what they're talking about and know what they're doing. For me, as a customer, that's the guy that I would want to buy. Setting aside the coolness and the quality of the product, hey, I need a new storage array. Which storage array should I buy? I'm going to buy the one that somebody can answer the phone and answer my questions for. I'm going to buy the one that an SE is going to come to my facility who maybe doesn't live in Chicago, but maybe lives in Minneapolis, where I am. I'm going to try to buy something that's well supported. And so that's where I would start when evaluating these systems. Consider where the people came from, who they are, what they did in the past. And this final one is kind of interesting. In most cases, we're in a world of commoditization. In most cases, hardware support and software support are two totally different things when it comes to most IT systems, most IT. It looks like a hardware product, but it probably isn't really a hardware product. The hardware support is probably handled by some big hardware operation. Your fan burned out, I need a new fan, I need a new power supply. That's going to come from a totally different channel than, oh my gosh, how do I configure this thing? And so it would probably be a good idea to think of hardware and software differently if you're buying an appliance. So how can you know you're looking at a sustaining product? Well, here's some clues, some technology clues. Is there a hypervisor? If yes, it's probably a sustaining product. And here's why. This is a picture of trucks on a train. Fundamentally, what is a hypervisor? What does it do? Why do we use a hypervisor? The old answer, at least the pitch originally, was squeezing more things onto one server, right? But we know that's not the fact. That's not the case. That's not what people do with VMware, for example. It's not about, putting 10 servers on one server, as much as it is building a data center that we can move the workloads around a little bit, while still, and this is the most important fact, while still having the systems each think that they're running on their own piece of hardware. So essentially it's a bridge to the past. It's trucks on trains. It seems to be in a truck, but it's really not. And this, I think, is the key to basically evolving and moving forward in sustaining IT infrastructure. Your first step is to virtualize it. Your first step is to break the connection, the hard link between application, operating system, physical server. And to put a wedge right in there and say application, operating system, virtual server, physical server, because then I can start moving workloads around. I can grow the physical servers. I can swap out a physical server if it dies and put a new one in. I could even use something like converged infrastructure, where I have a whole data center of identical or different physical servers, different from what I would normally use, and I can seamlessly move up and grow and all that. These are fundamentally sustaining products, but they're still cool. Converged infrastructure is cool. If I was on walking down this path, if this is the career choice that I would made, I would be excited about things like converged infrastructure. I would be excited about vSAN. I'd be excited about a lot of these technologies, because what it means effectively is that I can do some cool stuff, and I can maybe save some money, or I can improve flexibility, or I can improve performance, but nobody's gonna know, right? Remember the sustaining thing, leave me alone, get out of the way, IT, I don't want to talk to you. fundamentally, converged infrastructure is a transforming technology for this sustaining world, because what it means is that I can start doing some cool stuff in the data center without actually messing with anything, without actually bothering with the stack up above. And that's fantastic. So what is this stuff built on? Well, for one, it's built on commodities. It used to be that servers were intricate, specialized pieces of hardware that had specific little things, and we would make, oh, I need a special chip to do this. Oh, I need a special chip to do that. Remember, there was a time when most systems, even servers, not storage exclusively, even servers had 100 different ASICs. Everyone was designed and built from all different technologies. Now that's all gone. Everything's on CPU, Intel CPU. Everything's going to Ethernet. These are important transformations in that sustaining world. Another aspect, as I mentioned, is virtualization. The point of virtualization is that, like I said, you can move things around. It makes the server a commodity. But remember, the server is something that's hiding in the data center, and the customer never sees, the customer never knows. These are the keys to basically moving forward on this path. I already talked about convergence. So let's shift gears. Let's talk about that other path. Let's say you walk down that other path, and you said, oh, I need a transformative product. Well, what is it going to look like? The first, essentially, there's a lot of traditional products that are masquerading as this new world, this new transformative world. There's a lot of systems that are fairly old and fairly conventional that are being called software-defined or cloud, right? I mean, remember, 5 years ago, everything was cloud this and cloud that. Now everything's software-defined this and software-defined that. That's a lot of BS. I'll tell you what I think software-defined is and why it's important. And frankly, if the world doesn't agree with me, I don't care. We'll call it something else. That's why I said transformative instead of software-defined in here. So you're walking through the aisles, and you look at a system. It's got a hypervisor. Oh, that's a sustaining system. Oh, it's running Fibre Channel. It's running iSCSI. It's got a 2-controller architecture. It's scale up. It's, all these are sustaining technologies. You're walking through, and you see something really weird. Maybe it's a storage system that doesn't have controllers at all. Maybe it's just disks in a box with some CPU and stuff like that. And maybe instead of just 2 heads and a bunch of disk shelves, it's got 15 heads or some weird number of them. And they're all working together. Suddenly you're looking at a different thing. You're looking at a very different product for a very different use case. This is cool stuff. This is where a lot of the development, a lot of the thought in IT is going. And frankly, this last thing here, autonomy, is I think the most important thing. Essentially, we're looking for systems that will work on their own, that don't need to be micromanaged by the systems administrator. To me, that's the hallmark of this software-defined world. So let's talk about it. So what do we got here? Instead of trucks on a train, we've got drones flying boxes. Totally different thing. They both accomplish the same task, right? And frankly, drones flying boxes is way out in the future, so maybe we can think about that too. One of the things that you'll see, like I said, is scale-out architecture. True scale-out architecture. Now, sometimes I've seen some conventional storage systems or conventional server systems saying, oh, we're scale-out, we're scale-out. Here's a clue. If it scales to 4 nodes and that's it, not scale-out. In fact, if it scales to 8 or 16 nodes, still not scale-out. It's not scale-out unless it can go to n nodes, right? Where n is as many as we had money to test in our lab, right? That's scale-out. If, sharded, what does this mean? If every piece of the system has to have a complete picture of the whole system to function, it's not scale-out, it's not transformational, it's not next generation stuff. Essentially, if you've figured out a way to do a Vulkan mind meld so all 4 of those controllers can still know what every other controller is thinking and has a complete map of all the data and where all the data is, and no, that's still a conventional monolithic system. It's an awesome one, but it's still pretty conventional. What sharding is it's and MapReduce and things like that. The idea is, I don't need to know everything. I just need to know my little corner of things. Each of those nodes, each of those 50 or 500 nodes, only knows what it needs to know and knows how to get to the one that knows something else. So essentially, if I talk to a, if I'm looking for, let's go back to the the Google example, right? I'm looking for my Gmail, right? The first step is that happens under the covers is it figures out where your Gmail lives right now, and it sends you there. And then you're talking to the right one. So even though to you it feels like I'm always asking for gmail.com, gmail.com really doesn't exist. It's really just an abstraction of a whole bunch of segments of gmail.com where each one owns its own little corner of the world. And that's totally different from a cluster running Exchange, because in that situation, each node has everything. And those things just can't scale forever. So we're looking for some of these things. We're looking for software defined. And now I'm going to talk about that. So settle back, relax, and enter the no marketing zone of software defined. What is software defined? And why is it important? Here we go. So back in the day, we had computers. And computers are basically calculators, glorified calculators. In other words, it's a thing that you use to do something. Hey, I want to look, I want to calculate, do multiplication, right? I type it in the calculator, it gives me an answer, right? Nowadays, we do all sorts of exciting and important things with our calculators. We run Angry Birds and, we run video games and we fly drones with our calculators. But essentially, they're still just handheld people things. They're things that you use. You're a person, you interact with it, it's a computer. And computers are everywhere, right? I mean, this is a computer. It's not a very smart one, but it's still a computer. Back in the 70s, somebody had the wise idea that we could take one of these computers and we could make it not something that people use, but something that other people's computers use. So a server is a computer that computers use. What's an Exchange server? Well, it's really just a PC. And it really just runs Windows, but it's running a special application that your computer then talks to over the network and does stuff with and so on. It's set up in such a way that it's not supposed to be used. That's why a lot of servers these days don't have screens, don't have keyboards, don't have any of that stuff. They just sit in the data center because your computer is going to use it. Now, historically, how we set these things up, and this is that standard path, that sustaining traditional IT path, how we set these things up is me or you sits in the data center when it's cold and late at night, and we rack it in, and then we configure it, and we log into each one. Do you guys remember the days of IT when it was, when you were fighting, BIOS versions and drivers and so on? That's not gone, but thanks to VMware, it's less important now because we no longer have to match the BIOS version to the application, right? We just have to match it to the hypervisor. We no longer have to worry. This is why I made a joke about DR always failing. Back in the day, DR was the world's, it was terrible because everything had to match perfectly. Like, oh man, I got the wrong model NIC. It won't boot, right? Now that thanks to virtualization, we don't have those kind of worries anymore. But still, everything is done by you and me. Everything is handmade. Everything is artisanal, right? That's what servers are about. That's what all that stuff is about. Software defined is totally different. Essentially, the thing that I get out of this word, the thing that I like, the reason I like this word is because software defined infrastructure, in my mind, should be something that is truly integrated and that you should never touch. Essentially, the difference between a computer and a server is, do you touch it? This difference between a server and a real software-defined thing is also, do you touch it? Except the you in this case is IT instead of the end user. A true software-defined storage product is a product that vaporizes and dissolves and is gone, right? It's a product that you install and then is taken over by something else, by a platform of some sort, whether it's the virtualization platform or a cloud platform, and you just never mess with it again. It's just, it does its own thing. And how it does this is pretty cool. How it does this is by using an API. So to me, an API is the essential and critical component of software-defined infrastructure, and also the essential and critical component of this transformative IT. What that means, what is an API? What's the difference between an API and just doing stuff, right? An API is for applications to use. In other words, when you want to store some data, right, you can either write it to a file and go through all those kind of things, or you can have your application integrated with Amazon, and the application takes care of that. What's the difference? Well, the difference is, in a conventional system, you have to think about where am I going to put it, and how much space is it going to take up, and is it going to be where I need it later, and all that kind of stuff. With like the S3 API, you don't really worry about that. You say, I open a bucket, I stick it in the bucket, it's going to be in that bucket. And in fact, you know that it's going to get moved all around, and it's going to go from data center to data center and disk to disk, but I don't care. All that stuff is taken care of by the application. Essentially, it vanishes. It's storage that just totally vanishes. I mean, the same thing can be said of pretty much most true cloud systems. Think about iCloud on your iPhone, right? So somebody was taking a picture of the slide. You took a picture of the slide, right? Do you have an iPhone or Android? Okay, so we'll talk about Google then. Okay, so when you took that picture, I bet you're going to find it somewhere else, right? You're going to find it in your Google universe, right? Maybe it'll magically come down to your laptop or over to your tablet or something like that, right? That's pretty cool. It's really storage, but it's really a special kind of storage, right? Because it's storage that you don't ever see or touch or feel or anything. It just magically happens. It just magically goes from your phone to your tablet to your laptop to your google.com website, whatever. This is what's going on, and this is why this kind of stuff is really truly transformational, and why I think this whole software-defined world really matters. Because basically, if we as IT can build a true software-defined infrastructure, what we've built is kind of the real concept of that cloud, the idea that IT hardware, and all that is intimately linked together and does its own thing. And then we kind of move ourselves up and start thinking about IT in a different way. We start thinking in terms of platforms and so on. Back to what can I buy? So given this, if we're going to look at products and we're going to evaluate products and we're trying to figure out a way to build our own cloud platform, our own transformational IT systems, and we're walking down that aisle and we look at it and we see a monolithic storage array, or we see a server, or we see a monitoring package or whatever, that's awesome, and it may be useful for the other side of things, the sustaining side of things, but if it's not truly software-defined, if it's not truly scalable, if it's not like a true component of this cloud, it's actually not that interesting to you if you're walking down that path. So what can you buy? Well, there's a lot of things you can buy. One of the things that I noticed while walking through the group of companies here is that pretty much all the companies fell on one side or the other of this divide. And if you look at the table and you say, I could run Exchange on that, or something like that, or that would be useful in monitoring my Exchange or whatever, that's the sustaining side of things. And maybe if that's your path, if that's your way, you totally fell in love with that product, and that's cool. Then you want to start looking at the supportability and the features and all that kind of stuff. If, on the other hand, you looked at it and said, that's cool, but I have no idea what I would do with it, it's probably because that company's on the other side of the path. And I see this again and again. I see companies trying to present at events like this and trying to talk to folks about their products. And some of the folks are just, I have no idea what these guys are talking about. I have no idea what this product is useful for. And that's basically because it's on the wrong path for you. So that's what I had to say. That's what I wanted to say. What can you buy? Forget what can you buy. Think about what are you trying to do. Think about which path you're walking down. And then you can look at what you can buy. So who has comments or questions? And this is me. And if that giant QR code gets you to my mailing list. It really does. Anybody?
Thank you.
Awesome.